solved by the field format. So again, I will change the free format to the field format. Then I will take the first is actually the date value. So accordingly, we'll change it to date. And the format is this. So we'll take the same format here. Then this one is actually the time. So we'll take this to time and TOD auto. So now the third one is actually pressure. So let us take pressure here. Okay, the same which we have done in earlier examples. I'm doing the same steps again. So then load it. So now you can see this is very, very fine uh, uh, pressure data, and you can see very smooth buildup is there. Again, if you want to confirm that there is no mismatch, you can go ahead, click on edit data and see whether is there any mismatch. So click on this, you will see, yeah, slight mismatch. So what I will do, I will select it by the time plus value. I will take this one. Okay. So this is your so I have actually made sure that there is no time lag in the, and then I have taken the pressure rating at the time we applied shut-in. So now let us interpret. Okay, so everything is everything seems okay. So let us move ahead with the extraction of DP. Because there is only one BUP, so I will take only one buildup and let us plot it. Yeah, smoothing again the same. I'm not going to change. I'm going to take the same. Sure. So now look at this carefully. Again, I have three graphs. One is the semi-log graph, log graph, and then we have the this here I am having the same pressure and the rate history graph. Okay. So if you have any doubt regarding this, the steps I have taken so far, you can again ask. I can again repeat if you want. Okay, so now let us start the interpretation. Now look at this graph carefully, and these lines I can move, you already know. Okay, this I can move. So now I can see clearly there is a, I think, valve storage here. Okay, there is a valve storage. If some points are actually uh, lying over each other, so delta P and delta P values are matching here. So I can take sir, okay. Is this graph visible to you, Amir, or everyone? Now visible. Okay. So now, so this is the graph which I have just plotted after extracting DP. So I'm now actually trying to interpret it without going for the final solution. So without seeing the final solution, I am just trying to interpret it. So I'll try to interpret it very slowly. So wherever you have any doubt, you can ask me, you can let me know. So now this line I can actually move here or there. You can see. Okay. So from the graph, it seems that there is a valve storage here. Okay. So this line is actually giving me the unit slope line. So seems that there is a valve storage here in this zone. Okay. And again, it also seems that after some time, IRF will also come here. IRF will also come here. So this is just the my based on my understanding. I understood that there is a valve storage also. There is a IRF region. Looks like that there is IRF region, but there is a difference. There is actually noisy data in IRF region. So we will smooth it by applying the D convolution. So if you have any doubt regarding this, I can again replot. So I have just replotted the graph, got a derivative, and it is looking like this. And this graph is your semi-log graph. It looks very fine data. There is no noisy data, or you can say very less noisy data. And then, so let us start the deconvolution. Yeah, in deconvolution, again, I'll try to smooth it by applying 0.2. So let us see what happens. Okay. Is this deconvolution graph visible? Okay. So after deconvolution, you can see there is a there is very good IRF region has been developed here, and it has taken. So like there is one more thing I just want to tell you that one minute. Actually, I tried to smooth the graph by applying a factor of 0.2. But what I am actually trying to tell you, there is one more mode by which you can manually remove these points, so that there will be more, smoothing in the graph according to your requirement. So you can customize it, and you can remove all these red spots by applying this tool. So I'm actually trying to find it. I'm again going with the deconvolution. So I'm trying to apply it, suppose 0.2, but I just want to do this by my hand. So I think I can do this. Suppose if I want to remove this manually, I can do these corrections manually also. Okay, this symbol you can also use to clearly see the spots or the points of your data. So this is called the visible point. So it clearly shows you the points where you have the data. So after clicking on this, you can understand your data is here. But there is one more actually facility with this. You can actually manually change the points. So I'm trying to find this one. Yes, I understand. I can modify it, but yes, that is okay. But I think I can remove these spots also from the graph, and then I can run the smoothing at 0.5 or somewhere. Yeah, that I can do. But if I want to remove, suppose this point, so that I can have the better, this should be there. I think it was there on last time. Anyway, I mean, you can also use this as yeah, by using mouse. you can also shift the graph according to your usage, but that is not the good way. I just want to remove all these points from here. I just want to take these some points. So this is somewhere. Anyway, I'll see this and I'll tell you this in the next class. Suppose there is one more point here. So I just want to remove this point here. So I can do this manually. I'll see this and I'll get back to you next class. Let me see if it is removing or not. Yeah, I'll see this. Okay. So let us go ahead with these again with this 1 minute. Shift it here. So I'm applying again smoothing factor 2. So you will see the graph has changed slightly and some of the noisy data has been removed from it. So I'm taking this as like this. So now the graph will look like this. The PD curve is looking like this. I think this is the command. Okay. I can shift the graph according to my, yes, this is, I can customize it. So by the mouse, you can also customize if you want to, suppose shift the graph if you want to run. So you can, if you change it, it will change automatically and run it. And then click on this, okay. So graph, the main graph will also shift. So this you can do manually also. Yes, you can do this manually also if you are not comfortable, suppose in removing the points. So you can also do this by your hand. So again, let me do this one more time. I'll extract the main DP again. Yeah. So this was the main graph. And in this main graph, I'm going to suppose I can also, I would like also like to tell you one thing. Suppose if you had changed the shape of the graph many times and you are not now comfortable and you are not able to redo it, so you can again extract DP. Okay, with the same data, you can again extract the way I am doing this. If you are not comfortable with the suppose modifications, so you can again replot it by clicking on extract DP. So the same data will be replotted again and it will be it will look like this. So this is the this was your original graph or original this pressure derivative curve. So now I can do deconvolution. So in deconvolution again, I'm using a smoothing 0.2, 0.3. So then run and then okay. So the final graph will look like this. Okay. So in this graph, you can see some Velbor storage is still here. Okay, some here it is matching, here is it is leaving, so it is called changing Velbor storage, changing Velbor storage. Okay. Then now let us start. Now from the interpretation I can understand without going ahead with the final solution. Just see the graph carefully and try to understand what could be the answers. Like you see here, if I look at the storage, so for storage I can again go with the specialized line. I can create it and I can see somewhere, you can see here or here, you can see there is some Velbor storage. So I can draw this line. Now in case of this because this was the limited entry well, so let us see the slope of spherical also here. Yes. So now there is a hint also. You can you please revise your fundamentals. When we have limited or spherical flow, we have the slope of -5, minus 0.5. So here up to this point you cannot see any match, but here somewhere here, yes, there is a match in the line. So it is now confirmed that it was the spherical, and this some data the data or the information was given to you initially also confirms that yes, we were doing the well testing in a partial or in a limited entry well, okay, in a partial penetration well or limited entry well. So it is confirmed from this also. You can see the slope minus 0.5 is here. Now, if you look at the original data, again, I would like to extract DP. In original data also, if you click on this, now see somewhere here, up to this point, the hump line was very smooth, but after this, there is a significant difference here. So the difference or the this noisy data can be clearly seen here, and in IRF also. So if I plot the suppose spherical line here, so let us draw the again spherical line. It will also show you match here. See this? So it is confirmed that this was the actually spherical flow here. Or I can say if I look at the time you can say after 0.2 hour, after 0.2 hour, this flow actually started. So this line actually confirms, or this zone confirms it was the spherical flow. So it is also confirmed here. If you look at the wellbore storage, the wellbore storage is very weak, but it is there. Okay. So I can also draw this. Or you can also take the help of this line. So this line will also be here. Or this line is also in the IRF region. You can use this also dotted line. So I have the IRF also, I have the spherical flow, then there is a hump and wellbore storage also. Now, if you ask me that if we just make a guess, what will happen to the skin? Okay, so let us see now. We'll solve this problem and we'll see the final solution. Now we'll apply the model, because there is some wellbore here. You're not asking one thing, because I have not actually data, so no need to convolution here. Deconvolution, we will deconvolute the match is not good and we are not finding the good match. We can do this later also, but first try information if we model it. So let us model it. So in model, see these parameters carefully. We are going to again use the standard model. We are going to use the constant wellbore storage, because there is some wellbore storage. So let us take this as a constant. But the well in well model, you will see there is clearly a vertical limited entry mode. So click on this. Once you click on vertical limited entry mode, there will be some variables which will pop up, and they will you have to then change. So now you can see this window, this table. In this table, HW is given, but HW we already have, I think, HW value. HW value, I think, was 0.10. I think HW was 10 feet. So let us feed 10 here. ZW was 50 feet. So keep it 50. H was 100 feet. Pi, you need not to change it. Because this is KZ by KR. KZ by KR, permeability contrast. But it is not defined in the problem, in the statement. They did not talk about the permeability contrast. So we'll keep this as one, as the model says. Okay, now if you want to look at this schematic, I can also show you schematic here. This is the schematic. So you can understand the parameters which we are actually using here. So this is H, this is HW, this is ZW. Okay. Yeah. Is it clear to everyone? Just tell me if it is not clear. So once you select the model, there will be so many things to modify for you. You can modify accordingly. You can see even the schematic, what data you schematic, I can understand. Okay, This is HW. So suppose somebody, if somebody who doesn't have any idea, so you can explain them by schematic also. This is the meaning of ZW. So the parameters which you gave to me, I have just meters in this graph. So based on this model, I have modified the values here. Now let us move with the homogeneous model, unless it's until it is specified. Then boundary, use the infinite acting reservoir. So then generate it. See where you are actually seeing the graph. So now based on the model, it is improved yet, but I will improve later. But before improving, let us talk about this. This I have given, this has giving me, this red one is del P. These graphs, 1 minute. If you just compare it, here I'm unable to see any 5 minus 0.5 slope line, but in white line I'm unable to see this because this looks very smooth. It is showing me the directly IRF region, but in my actual data, IRF region came later. Before this, I was seeing the actually spherical flow, okay, because of this zone. But it is, I think, not available here. So let us improve it. After improvement, you will see what will happen. Okay. Amir, was this clear, or was there any time lag? Should I repeat? What is the meaning of yes? Was there any time lag, or should I? Okay. Okay. So now see this. Okay, so let us improve it. So in improvement, all the values, it will run, this will improve over all the variables. So let us run it. Now why it is taking time? Because you are asking software to run improvement over so many variables. So sometimes when you have very complex problem, you will not be able to actually find their answer immediately. It may take some minutes, okay, to take the best call. Then it will run over, or if you want to reduce this, whenever you improve, you can actually ask the software to run improvement over a single variable. But other variables you can just remove, or you can ask the software to, suppose you want to run over the only over the Valbor storage, then click on this and this symbol will remove. So then it will not take much time. But if you are asking software to run over the number of variables, so it will take some time, and then after some time it will give you the best count. Now just look at the graph which I have just improved. So after improvement, you can see this is showing me the Valbor storage here. Again, it is matching with this also, but what is happening? This is not matching with this. This spherical flow along with IRF, it is not at all matched with it, but entirely matching with delta B. So what is actually happening? So whenever you have any problem in the match, what you should do, you should look at the, have seen the spherical flow. So this one, for that again you can actually improve it. Try to improve it, like spherical seems okay. Seems okay. Let us simulation slightly larger. What will happen? Let us see. Make it 90. If it is going to give any advantage. So this is the best which the software can do. Okay. So this is the best. And now look at the MTR data. Yes, Chandra said something even after specifying vertical limited entry. The model is not showing spherical flow. Why? Yes. Yes, it is not. Yeah, it knows this, but it is not going to show you vertical. Yes, but it is like when I actually perform this improvement, you can actually, yes, you can see it was trying to match it with this, but it was not helping, and the model also did not match, because if I change, if Chandras, if I try to match this, maybe the soft model will leave this graph some here. So the model tried to match entry well, and it tried also. So but it gave we can also see if you want to suppose match it with, and you can also change your lose the track here somewhere. So whenever we have any problem, we should always try to see the our semi-log graph. You should always try to see the semi-log graph. In semi-log graph, I am seeing that there is a, yes, Amir, I'm answering the same. In semi-log graph, it has entirely matched with it. But this zone, the software did not help, and it has not shown me the match here. But if I change more, if I do more changes, what will happen? The state of this match will actually lose further. Maybe that in between here you are not giving the good match, and also here you are having the reasonable match, but that is not the good match. We should always try to have the best to best match, and for that we have taken the relevant model also, and it has also given the, it has taken the vertical limited entry. You can see the data. Well is vertical limited entry, reservoir is homogeneous. But if we can do more corrections, we can try it. So it will not end like this. You can again, like reservoir model, we took homogeneous, but in reservoir model, Amir, there is no limited entry model, because limited entry means it is also in a single reservoir. So for that we can take homogeneous reservoir only. Otherwise, if you change the reservoir, it will be two porosity, two layer radial composite. So then it will change the character of the reservoir. But in case of limited entry well, we are taking homogeneous. So if I change it again to suppose some other entry I have taken, then boundary I have considering infinite. I am not considering fault, circle, parallel faults. Consider infinite. The relevant details I have also given to the improvement cannot work over this data. So it will give you the reasonable match. Why I'm saying this? Because it will be confirmed always through the semi-log graph. See this semi-log graph. If you are trying to suppose push this red one in the upper side, if you are trying suppose, so then it may happen that it will lose the track in somewhere here. So we can do these iterations, and we can actually make changes. And I can also look at this. Yeah, it is also giving me the reasonable match with this. So that is actually the correct answer for the match. But here, yes, it is not going to give you the here match. So That is the best the software can do, because if I 1 minute, let us draw the spherical flow. It tried to match here only for shorter time, but it could not very software could not work on this, and it has given the match for changes into this. Maybe you will find some, it will not work, I think, because that match I will always try to see the MTR graph always. To this point, this is entirely matching, but here also it is giving me the reasonable match. So here it is losing track, somewhere it is giving match, again it is losing track, but it is not very far. So if you are trying to suppose changing it, so then it may happen that the MTR graph will lose track somewhere in ETR. So then again you will see the problem in the data, then you will not. The skin is 13.4. Skin is positive, and it was also a guess, because initially before solving this I told you there will be there was significant hump. So this hump indicated that there is a skin. There is one more. There is question. Should we try after deconvolution? Yes, we can also do this. These combinations you can actually perform over and over again, and you should do this so that you can have the best to best. Do this, extract DP again. Spherical flow. Delete. So let us draw this one again, extract DP. Yes. So let us try deconvolution. Point 2. Run. Okay. So model will regenerate it. Now see, again, if we are looking at this, again you can see it is giving me the losing track here somewhere. So let us try again improvement here. The model values will not change. We'll try to improve it further. So run it. Let us see what happens. You see, it is actually running, but it cannot take the data which is here. So it is trying to match with the data, but if it goes down, it may lose the track somewhere here. No, it is also always noisy. I just try to reduce the some amount of data. So I'm actually trying to confuse the model. Yeah, I'm not actually making it smooth. It is not always smooth. Data whichever I'm having, it is actually noisy here. It was noisy in this zone. So if you ignore the data, it doesn't work like this. Again, you can see if I draw the suppose spherical line here. Yeah. Now you see spherical line is not giving me the match up to this point, but here it tried to give the match slightly, but just slight match, not the entire match over this, because this is the hump area, but here it tried to actually match with the spherical. Even after deconvolution, did I get any improvement? Let us see in the values. Yeah, earlier it was 13.4, now it is 16.4. The skin value is 16.4, permeability 53. Again, if we improve further, let us see what happens. I am changing the skin value to 10, and it is suppose 9. I'm reducing the band of skin. It is asking 16. Okay, let us see this. 16. My opinion, it is the good match because I'm seeing the MTR line. It is giving me the best. It also have seen before the deconvolution. Good match, but somewhere it is losing the points, somewhere it is not losing the points. So that could be the this software. Okay, and it work in this area. In this area, it was not. It tried to run the simulation, but very small area, very small zone. If you look at the time, it may be like this line first. Yeah, this point up to this and up to this. This is a very small area where the software tried to simulate with the spherical flow, but later data, it could not work out, it could not take into consideration, and immediately it shifted to the IRF region. Okay, so that is the, because in this we are not finding the match, so we are just getting confused. So but whenever you have any confusion, just always look at the MTR data. So this is going to give me the good match at least. So that I can say from the MTR data that the match is almost reasonable. So look at the answers. Answers are Valbor storage is 0.00105, skin 16.7, K 53.3, KH 5330. And you should also know that whenever you release the information to customer, you also have to tell them the reason why it is happening, what could be the reasons. So your reason should be validated, like this partial entry well. Suppose there is some other phenomena which was not understood by the software, or the we have to modify. So then try to have always the, so that you can have the closer answer, because this software, I also told you, always not correct, and then they are not going to give estimate what could be the best answer. So we are trying to simulate, and we are trying to have the best fit over the data, and we are trying to have the best answer from this. Again, the some values model, some if you run the simulation over a particular band, information will slightly improved, and but more or less it will remain closer to these values. Yeah, if you have any answer questions now, please. Anyone who has, whenever you will run the simulation, that sometimes like in the previous example, you have seen two PBUs, and there are you did not see the entire match. Always help, even when you have the very complex data, this simulation trained challenged, so it will always try to give you the best to best result. But if the software will always try to give you the closer answer, but exact, okay, not exact. So if it is matching exactly, It is good, but trying to run simulation, we're trying to just model with the information, and we're trying to understand what solution for the problem. And tomorrow we'll see two more examples to the data when we apply the workover, like acidization. So tomorrow again we will solve some at the same time. If you have any question from this, question, and I will stop here if there is no with the two new problems. Okay. So these this problem to you now. Okay. Bye everyone.